Okay, let me share the screen. Okay, so in today's we're going to talk about the MiniCPM. So MiniCPM is a small language model, which is a powerful language model that can understand and respond to general user request without needing a massive amount of computing power. So that's the idea behind the MiniCPM. In this research, uh, uh, the family of new small fish model has been introduced with only 1.2 and 2.4 billion parameters, which can easily outperform a large language model. In today's session, we will be talking about the 3 points: overview and related work. We'll go through how the previous work has helped developing this technique. Second, we will discuss the method and approaches used within this paper. And third, we will look at the results, final results. Okay. So, going through overview, the language models are like supercharged learner, but they come with some challenges. One issue is that they run because they require a lot of computing muscles. It is like trying to learn every book in a library at once. This means that they need computers and a lot of energy, which can be costly. And the other edge, and another challenge is that the LLMs need massive amount of data to train on. Just like we need a lot of practice to become a good learner, LLMs need tons of text and information to become proficient. So this can be handled. This can be hard because collecting and storing all the data takes a lot of resources. So basically, we can say that large language models are amazing but expensive to run and train. On the other hand, small language models offer cost-effective alternative, but they are like powerful but require less computing power. So, so in order to perform, they need some extra training and adjustments, and they cannot handle everything like LLMs, but uh, improvements can be made. Okay. So in this paper, the researchers are trying to solve the three main challenges that are in the way of developing powerful small language models. The first challenge is the inherent trade-off between the model size and the capacity. Like LLMs can be access and process massive amount of information, which allow them to perform complex tasks and general predictive text forms. However, training and training LLMs require significant computing power, which make them expensive and not always the best choice. On the other hand, small language models are more efficient to train and run due to their smaller size, but it can restrict to understand complex concepts, tasks which require visual knowledge base. So for that purpose, uh, the three ways has been addressed to solve these challenges. Uh, so in the mini CPM, this paper in this paper, the three approaches has been used to address the challenges. Uh, the first hurdle is finding the optimal hyperparameter, which are essentially the setting that fine-tune the learning process. So these settings can significantly impact the model's performance, but manually searching for the best combination uh, is time consuming. So to address the challenges, Bayesian search has been used. It's a technique that helps identify optimal hyperparameter settings like learning rate for the small language model, and this can be significantly improve of the model without need for the extensive manual tuning. And the other thing is CPM tackles the limited capacity issue by focusing on training method that allow the model to efficiently utilize its parameter. It's like focusing on efficient training and techniques techniques like weight sharing. So by doing that, the mini CPM can achieve impressive results despite their smaller size. And the last technique is WSD, the warm up still decay scheduler. So this will act like a steady learning process, which allows for continuous learning, avoid dramatic change that could become hard for the model's performance. This stable learning environment contributes many CPM's uh, success. Moving to the next slide. Okay, discussing the methods used in this uh, uh, to assess how well the CPM understands general language. So the authors have used two benchmark sources. The first is GLU, General Language Understanding Evaluation, and SuperGLU. These benchmarks evaluate the model on various tasks like questioning answer, natural language interference, and semantic analysis. By performing well on these tasks, this merge these tasks, MiniCPM its capacity in handling the broader range of language-related changes. Comprehensive evaluation uh, helps building the MiniCPM position as a powerful tool for NLP. And the second is DSD learner scheduler, learning rate scheduler, like the we earlier about the stable decay scheduler uh, it is the key factor that contributes to mini CPM success in the innovation. By W, it's like uh, it's like a new student. We can say as a it's like a new student. We can overload them with a lot of bunch of information to start with. So similarly, the WSD scheduler carefully manage the learning rate initially. Then warm up phase where the learning rate gradually increase allow the model to gently and efficiently adjust the training data. This is the followed by a stable phase where the learning rate remains constant, enables the model to learn efficiently. So finally, the decay phase where the learning rate is gradually decreased, helping the model to fine-tune its acquired knowledge and avoid overfitting. This well-managed learning process and under the guidance of the WST Schuler is a significant factor behind MiniCPM and its performance. Oh, okay, so the this is also the main approach used. Like MiniCPM used two-stage learning strategy to maximize its efficiency. The first stage is pre-training. It is like laying the foundation for the model. the model is exposed to massive amount of datasets of general text and coding, allow it to learn the basic building block of language. So this helps the model with a fundamental understanding of grammar, syntax, and how other related and how words are related to each other. So in the second stage, the supervised fine-tuning stage, the model receive most specific training on a smaller, high-quality dataset tailored to a particular task. It's like imagine having a skilled uh, skilled model. So this targeted training allow the MiniCPM to excel on various tasks without needing to be completely trained from scratch every time. Okay, SFT. Talking about the results, here we can see that the comparison has been made with the different language models. Uh, Although this comparison of different language model includes MiniCPM on a base task, even though it is smaller than some other models, but it still holds its own across the. Uh, it even The mini-CPM strikes a good balance between power and efficiency. It is important to remember that these models are tested on different things, as mentioned on the top. So direct comparison is not always the perfect option. But overall, mini-CPM shows great promise, especially for the tasks that require understanding NLP. Okay. So here's the model comparison. So the language models can be fine-tuned to better understand the human preference, but this can come with a cost called the alignment text. For instance, training a LLM to translate text in a way that readers more fluently for the people, like using simple language, might mean it scores lower on the other benchmarks that focus on uh, technical accuracy or capturing even smaller details in original text. So, as shown in this figure in this table, we see several language models performance score bench benchmark like text-to-text translation on the y-axis with the number of parameters on the x-axis. So the mini CPM improved their bench score after DPO, which is a alignment technique for human preference. But here we have not in the figure we have not shown how this performance impacts performance benchmark. Okay. So, to conclude this paper, in this paper, introduce the mini CPM, which comprises of two small language models, 2.4 billion meter model and 1.2 billion parameter model. Both are non-embedded parameters. Both have non-embedded parameters. So these models demonstrate performance comparison of their language counterparts of large language models. Uh, so training methodology are scaled both in terms of model and data size, offering potentially applicable in the development of large language models. So the introduction of WSD scheduler is notable for prompting continuous training uh, uh, and explaining compelling training dynamics. So further, along with the MiniCPM family, DPO has been introduced along with long context and MOE version. So talking about the further detection includes in-depth analysis of the loss decrease in the decay stage, enhancing the overall capability of MiniCPM by scaling in both model size and data size. I think that's all. The So here the collab link and the link of the paper has been given. If anyone wants to access, they can easily use it. That's all. Thank you for your time.